Hello, can you hear me?
Yeah, sir.
Okay, so you have some doubts from the test that you have given last week.
Yeah, sir.
Share the doubts. How many tests have happened so far, Alan?
Uh, Four actually, but I couldn't give the one yesterday. I had like a physics practical in school.
Okay, you are getting uh, 209, 155, 189.
Yeah, sir. But the last two went up by a little bit. There were some corrections.
Okay, fine. You share your doubts.
Yeah.
There are three rods that are connected like this. They are identical massless rods connected by hinges to each other. The outmost ones are hinged to the ceiling at A and B. The distance between these points is twice the length of a rod. This length is 2L.
Right.
If the rods are of length L, a weight of mass M hangs from here. If least force is applied onto hinge D to keep the system stationary, if least force is applied at a certain angle theta, find the angle made by the applied force, minimum force to keep it stationary.
Right.
The rods are massless and weight is hanging from here. The distance between the points is twice the length. Okay. So technically, technically, all of this is not super important because it will swing towards that side, right? It should
Right.
swing
Yeah. Yeah.
like this.
Yeah. Right. Yeah.
So all of this is massless and all. We don't care about it. If there was no force, it would have swung like this a little bit
Right.
to make it vertical beneath this.
Yeah. Right.
So all we have to do is find the torque of this weight
Yeah.
about this, right?
Right. Yeah.
And then that torque has to be somehow counterbalanced by this.
Right.
Okay. So, okay, fine. So least force is applied. But there is tension and all. So T, T1, T2, T2, T3. There is tension also.
Yeah.
To keep it in equilibrium, you have tensions, vertical component should balance mg, and the total torque about this point should be zero,
Right.
right?
Yeah.
Uh, right. So did you try all this? What happened?
Um, I tried the torque one, but I didn't get it.
So tension you didn't take.
I took, but I wasn't able to eliminate all the variables.
Okay. So let's try it out then. This is L, this is L, and basically this much is L. This will be,
Right.
and this will be adding up to something, to L.
L. Yeah.
So if this is X, this is L minus X,
Right.
right?
Yeah.
So from there we can find out the ratios for these angles alpha and beta,
Yeah.
right?
Right. Right.
We need T1 cos alpha should be equal to mg, and we have T1 sine alpha should be equal to T2, right?
Right. Right.
Similarly, we have T3 cos beta should be equal to F sine theta,
Right. Yeah.
and T3 sine beta is equal to F cos theta plus T2.
Yeah. Right.
No, wait,
Minus.
minus. This is what it is.
Right.
And then you have torque equation. T1 will have no torque. The torque due to these two forces will cancel.
Right.
We will have torque due to T3, F least, and mg, right?
Right.
So let's find torque due to mg first. So it is acting like this, R cross F. So this point, we need perpendicular distance to this, right?
Yeah.
So this distance matters, right?
Yeah. Right.
So it will be mgx, right?
Yeah.
And this torque is clockwise. Let's put a minus sign to clockwise torques.
Right. Yeah.
This torque, this force is T3, and we need force is acting like this. So we need the perpendicular component of it, and the distance would be this much, right? We can say it's a vertical force acting like this component of it.
Yeah.
And this is the
Right.
distance,
Right. Yeah.
which is L plus X.
Right.
So we need T3's component in that T3 cos beta, and this is
Yeah.
going to be counterclockwise. So
Right.
plus T3 cos beta times L plus X. And now this force, so we can say that there will be one component like this, one component like this. The component like this has a torque of with this distance, right?
Yeah.
So L cos alpha is the distance,
Right.
right?
Yeah.
So that torque would be like this counterclockwise. So plus F cos theta into L cos alpha.
Right. Yeah.
And F sine theta would be a torque that will be like this, right?
Yeah.
So that would be clockwise. So minus F sine theta, and the distance is again L plus X here,
Right.
right?
Yeah.
Should be 0.
Right. Yeah.
And now cos alpha and all, and cos beta I can write. Cos alpha is base by hypotenuse. So maybe I should not write. Okay, let's keep it like this for now. We need force to be least. Force to be least. So basically, you have to solve for force and minimize it, right?
Yeah. Right.
This force equation has T3 is involved in it, and T3 is here also. T2 can be eliminated. Okay, we have to slowly eliminate everything. So T2 is T1 sine alpha,
Oh, the
right?
T3 cos beta will completely get cancelled.
Where?
So T3 cos beta
Uh,
is F sine theta, and that is already there.
okay, so we are getting this thing. We have used this. We are getting F cos theta L cos alpha is equal to mgx.
Right.
Okay. Uh, so from here, we have to eliminate.
Alpha and X.
Hmm, okay. So we need to use these three.
Yeah.
So we know that T1 sine alpha plus T3 sine beta is here. It is too complicated. This is going to be not the way to do it, I think. There has to be something that we are missing.
Right.
This is too much complications for a question in mains. So three identical massless rods are connected by hinges to each other. Outmost ones are hinged to the ceiling. Distance between 3 points is twice the length of a rod. Weight is hanged onto hinge C. So L, L, and L. Okay, we have to make some simplifications. Like we are missing something. So this
Cos
is
alpha we could
2L.
have eliminated anywhere because we could write it in terms of L and X.
Hmm.
The cos alpha anyway we could have eliminated. We could write it in terms of L and X. Then only X we would need to eliminate. And I guess maybe we could differentiate that to try to get its minimum value.
I'm thinking of something simpler. I mean, there are still too many variables. Like,
Yeah.
what can we say about the tensions? Are they going to be different or what? That's what we have to think of. So, what I will do is apply, Lami's theorem, right?
Yeah.
Three forces equilibrium.
Yeah.
So, there is weight, there is T1, T2, and then there is T2, T3, and F.
Right. Yeah.
For equilibrium, we can apply Lami's theorem for these 2 points.
Yeah.
We can say that this angle is alpha, and let's say this angle is beta for now.
Right.
And can we make any assumption about that? It's LL, it's an isosceles trapezium.
Yeah.
Uh, it is possible that alpha is equal to beta. Is it obvious? Oh, it has to be, no, then. 1 second. Let me think. Is it possible to arrange it in such a way that the angles are different?
We don't know if that 2L and that bottom L are parallel or not.
It's not given.
Yeah, I've not said.
Right. Hmm. But for now, I'll assume that it is parallel because in the figure it looks parallel.
Yeah. Okay.
Let's assume alpha is equal to beta
Okay.
because if it is parallel, it has to be same then.
Right. Yeah.
So if we assume that, then our things will be, if force is T1, T2 here, and T3 here, we'll get T1 by 90, right,
Yeah.
is equal to T2 by this angle, right?
Yeah. Yeah.
This angle
360
is
minus 90 minus alpha.
2 pi minus pi by 2 minus alpha sine.
Right.
So it will be basically negative sine pi by 2 plus alpha, right?
Right. Yeah.
Pi by 2 plus alpha. Sine pi by 2 plus alpha is cos alpha, right?
Yeah.
So it is negative cos alpha,
Right.
correct? No?
Yeah.
Is equal to mg by sine alpha, right?
Right. Right.
We are getting T1 is equal to T2 by negative cos alpha is equal to mg by sine alpha,
Right.
okay? And from here, we are getting, let's call this as alpha also. We are getting f by sine alpha is equal to T3 by 2 pi, same thing. Wait, this angle is theta, this angle is alpha. Okay, so, okay, so this whole angle is pi,
Yeah.
pi
180.
plus theta, and this will be pi minus theta, obviously.
Right.
So it is sine pi minus theta, so sine theta
Right.
is equal to T2 by theta plus pi minus alpha,
Right.
sine of pi plus theta minus alpha, right?
Right. Yeah.
So that is going to be negative sine of theta minus alpha, right?
Yeah. Right.
That is going to be sine of alpha minus theta.
Right.
You're getting f by sine alpha is equal to T3 by sine theta is equal to this
Yeah. Right.
for equilibrium, right?
Right.
And now we can write our torque equation. These are force equations, right?
Right.
Do you understand what I'm saying?
Yeah.
Now we can write our torque equations. So, right, so
Oh, if it's in equilibrium, we can take it at any point. So it'll be easier to take it through like that mg point.
we were taking torque about this,
Yeah, because if it's equilibrium, then you can take anywhere.
right? Yeah, you can do that. So let's take torque about this then, because it's stationary. So they will get just torque due to this force and this force, right?
Right.
So T3, this is alpha angle, this is pi minus alpha. You have cos pi minus alpha this way, which doesn't matter. Sine pi minus alpha this way. T3
Right.
sine alpha, right?
Right. Yeah.
Multiplied by L.
Right.
And again, f sine theta multiplied by L, right?
Right. Right.
So we are getting this then,
Yeah.
correct? So let's eliminate all the unnecessary things like T3 and all. So
Oh,
T3 by sine theta is actually
this
f
was
by sine alpha.
we didn't. This was useless. We already got
Uh,
that from the Lamissian.
right, we've already gotten that. So we have to take it at some other point. We should take it here. Because those points we have not used, no? Correct?
Yeah.
Okay, so by the way, from here only, we are getting T2 value in terms of mg, right? Minus
Yeah.
mg cos alpha by sine alpha, right?
Right.
And we can put that in this, right?
Right. Yeah.
And we are getting f by sine alpha is equal to minus mg cos alpha by sine alpha minus theta, right?
Right.
So this cancels. And
Yeah.
f is coming as minus mg cos alpha by sine alpha minus theta, right?
Right.
All we need is to remove alpha somehow,
Yeah.
right? Okay. Uh, T3 and all I will not involve because I have already removed it. I
Oh,
have a
I got it. So if you're assuming that L and 2L are parallel, then we
hmm,
can use the alpha angle, like cos alpha, sin alpha. We can get those values now.
right, because we are going to get this will be half and this will be half.
Yeah.
L by 2, L by 2, right?
Yeah.
So this whole angle is alpha, we are saying.
Yeah. Pi by 2 minus alpha.
So this much will be alpha minus pi by 2.
Oh, yeah. Alpha minus alpha. Right.
And we can say cos and all, or we can say perpendicular by hypotenuse. So sine of alpha minus pi by 2 is half, right?
Yeah.
So this is minus cos alpha is equal to half. So
Right.
cos alpha is minus half. So alpha is 2 pi by 3 basically.
Right. Yeah.
You're getting f is equal to mg by 2 sine of 2 pi by 3 minus theta,
Right.
right?
Now we need which theta gives least F.
Right. So we have still not done the torque part, right?
Yeah.
We have done force
We didn't get,
equations.
yeah. We didn't get anything from the top.
No, we have not done torque at this point, right?
Oh, yeah. Yeah. Right.
We can try it out now and see. We have already got an F as this, so angle made by the applied, we need to find theta. So this is least apparently. So
No,
this
I mean,
should be
if,
maximum.
yeah. So we can just say sine needs to be 90.
Theta is 30,
Yeah.
right?
Yeah.
What is
Right.
the answer?
Uh,
Check once.
yeah. 30.
Okay, fine. So basically you have to make some assumptions here because otherwise it's not coming.
Right.
The assumption that it looks parallel, so let's assume these angles are same.
Yeah.
And then instead of doing like all the equations one by one, use this
Right.
equilibrium of three forces at a point, Lami's theorem.
Yeah.
That gives us direct calculations we can make. Directly, we can eliminate unnecessary things and
Yeah.
get an expression for F.
Right.
We did the torque equation, we didn't get anything actually from there.
Yeah.
We just did equilibrium at these 2 points and we got this equation, and then from here we can see what? This equation here, we saw T1 is this,
Yeah.
or T2 actually we
T2.
saw, because we can connect it to T2 directly.
Right.
So T2 is known, and then we put it here, we got F as this.
Yeah.
And then from the diagram, we know if we make this assumption, we can find out cos alpha.
Right.
And then we got this expression. So F depends on the angle. So we are maximizing this part.
Yeah.
Okay. What is the next one?
1 second.
Okay. Mr. X walks up 16 steps, walks 16 steps. He can go either 1 or 2 steps at a time. There is explosive material on the 8th step. 8th step is not allowed. Okay. Number of ways in which he can go up 16 steps, assuming he starts from the ground level. Number of ways to go up 16 steps. Right. Starting from ground level. Okay. So, right. So you can't go to step 8, right?
Right.
So finally you have to reach here. Let's say ground level is here, 16th level is here, 16. And step 8 is here, right?
Right.
You have to exclude all paths that go to 16 from 8, right?
Yeah.
Basically, what you have to do is
We have to skip 8 every time.
you have to skip 8 every time. I'm trying to find out the how we'll do the overall count. 1 second. So without any restrictions, going from step 0 to 16 is some ways, right?
Yeah.
From there, we have to exclude all the paths that include 8,
Right. Yeah.
right? So all the paths that are basically from 8 to 16, right?
Right. Yeah.
See, any path that includes 8th step will mean from 8th you have reached 16, right?
Yeah.
You have to exclude all these paths,
Right. Yeah.
right? So, fine. So we just have to now count total number of ways to go from 0 to 16,
Yeah.
and we have to exclude from there number of ways to go from 8 to 16.
Right. Yeah.
Do you understand?
Yeah.
And each time you can go 1 or 2 steps, right?
Yeah.
Okay. So what we will do is we have to do it by a recursion method. So by recursion, I mean, let's say you are at the nth step, right?
Right.
Let's say an is the number of ways in which you have reached the nth step.
Right.
You could have come here from n minus 1 or n minus 2, right?
Yeah. Right.
These are number of ways to reach an minus 1. These are number of ways to reach an minus 2, right?
Right. Yeah.
From here, you could have jumped directly or gone 1 step at a time.
Yeah.
So if this is my recursion, no?
Yeah.
Basically what I'm saying is counting the number of ways to reach nth step is can be done in 2 ways,
Right.
right?
Yeah.
You can reach it from this or you can reach it from this,
Yeah.
right?
Right.
We have to solve this recursion and find out what is A16,
Yeah. Right.
right? So you should see that this is a direct Fibonacci recursion, no? Right?
Right. Yeah.
A0 is 0 is 1, right?
Yeah.
A1 is also 1 only, right?
Yeah.
A2 is 2, however. Do you
Yes.
understand?
Right. Yeah. Yeah.
Second step, you could have gone in 2 ways,
Yeah.
right?
Right.
So what is the sequence? 1, 1, 2. A3 will be A2 plus A1, right?
Yeah.
And you see that this is Fibonacci series.
Yeah.
Do you understand what I'm saying?
Yeah.
So basically, we have to find A16, right?
Right.
You can just list it out like this now.
Yeah.
Let's list it out. 1, 1, 2. Okay, wait, this is A0. This
Yeah.
is A1. Okay, so this is 2, 3, 5, 8, 13, 21, 34, 55, right? 55 plus 34 is 89.
89.
89 plus
146. 144.
50, 139, 144. So 233 after that, right?
Yeah.
233 plus 144, 377, right?
Right.
And then one more, let's add 577 plus 30,
610.
677, 610. So let's see how many are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is A14.
Right.
So this plus this 987, right?
Right.
And 987 plus 1587 plus 10.
1597.
That is without any restrictions.
Right.
A16, right?
Yeah.
Okay. And so 1, 2, 3, 4, 5, 6, 7, 8, 9. This is my A8, right?
Yeah.
1 second. Number of ways to reach A8 is 34 only. So maybe I'm making a mistake then. 1 second. Because my answer is becoming very big, no?
Yeah.
Something is going wrong. He has to walk 16 steps, going either one step or two step at a time. I am doing number of ways to reach place step 16. Uh, but something is wrong. 1 second. One step or two steps at a time. 8 step is not allowed. AN was the number of ways of reaching nth step. You could have reached there from AN minus 1 or AN minus 2. Okay. So number of ways of reaching 8th step is 34. That's correct only. But we can't reach 34. So basically we can go to A7. Okay, the recursion is broken because of this skipping thing, no?
Yeah.
Because A9 is weird, no? It's not fitting the same pattern.
Yeah. Right.
Okay. So A9, the only way to reach it is A7, right?
Yeah.
Right?
So we can say from A
So
only
A9,
until A7.
A9 will only be A7, no?
Yeah.
Number of ways of reaching this will become 21 then, right? Do you
Right.
understand?
But it'll be 22 because for A9 it'll be one more step.
What? How?
Like from A7 to A9 you'll have to take one more step. So
Right. So 22, right?
right. Yeah.
Let's think of A10. You can't go it from there from
Only one
A8,
way.
right?
23 isn't it?
From
No, I don't.
A9 only, right?
Yeah.
So it starts again from here, basically, right?
Yeah. Right.
So 22 and 23 will come here, right?
Yeah.
And then you do again normal.
Right. Right.
Okay, nice. That's the thing to notice.
Yeah.
So now you let's do 22 plus 23. This will be 45, right?
Right.
This will be 68.
Right.
This will be 105 and 113.
Right.
then it will be 181, right?
Right.
This will become 281 plus 294
Right.
and add 181 to it, right?
Yeah.
So 294 minus 19, right?
Right.
No, so 494 minus 19. So I'm getting some 475 or something.
No, it's not there.
What is the answer?
1 second.
1 second. It is very close. We are on the right track only. 441 or something, it will be 442 or something. So right now what we have counted is 475 ways to reach here,
Yeah.
but where we went from, all of this was fine, but then we skipped to A9, right?
Right.
22 ways of reaching
It
here.
is 441.
Something really small is going wrong. 34 subtracted from this is 441. Can you see what I'm saying?
Yeah.
Why is it subtracting 34? 475. We had anyway skipped it. No. Assuming it starts from ground level, number of ways of reaching it without, we have already done the part of leaving out A8, right?
Yeah.
We reached A7 in 21 ways, then we moved to A9 in 22.
441 is 21 square. And A7 was 21.
But that is like, that doesn't make any sense. You're just noticing random patterns.
Yeah.
That doesn't make any sense. What makes sense is this is much closer to what we are saying. Why has he
Yeah.
done this? Is there any solution that you have found? Or is there any solution for this?
No, it hasn't come out yet. This paper was, I think, day before yesterday. So
Okay, 1 second. 475. Walk 16 steps, 1 or 2 steps at a time. A8 will be 22, A9 would be 23. There is only one way to go from A8 to A9. After
right.
that, there are two ways. So A10 should be 22 plus 23. All that is fine. A16 should be 475. And are we already skipping in all of these ways? We are skipping A8, right?
Yeah.
Or why would we need to subtract 34? 1 second. Let's do the same problem, but for very small numbers, right? So let's go up to only 5 steps.
Right.
And let's say step 3 was bad.
Right.
So we are A0, which is 1, and then A1, A2, A3, A4, A5, and this has to be skipped, right?
Right.
Normally, I would have done 1, 1, 2, 3, 5, and 8. This is without any restrictions.
Right.
But let's think of what our same logic. 1, 1, 2. We can't go here. So
Yeah.
A4 for us should be from 2 only one step, right?
Yeah, right,
It should be 3.
right,
This should be 4, right?
right. Yeah,
Let's do one more step here. A6, A7. Normally it would have been 13 and 21, right?
yeah,
This would be 7 then, and this would be 11 according to our analysis, right?
yeah,
So, according to our analysis, this should be 7, right?
right,
But according to what he's doing this minus 7 minus 3, 4, right?
right.
Do you understand what I'm saying?
Yeah,
Our answer is 7, his answer is 4 for A6.
yeah, right,
Now, let's think about whether that makes sense or not. I need to reach A6. I can't go on A3, right?
right.
So there is one step, A1, A2. So what is the sequence? A1, A2, A4, A5, A6. That's one way, right?
Yeah,
A1,
no, directly to
A2,
it.
A4, and then A6,
Right, yeah,
right?
yeah.
Then A1 to A3 we can't step on. So we have to go to
A2
A2 then, right?
directly. Right.
Oh, we can directly go from A0 to A2,
Yeah,
right?
right.
A2 and then we can do
A4.
A4, A5, A6,
Yeah.
or
Or
we can do
A2, A4, A6.
A2, A4, A6, right?
Yeah.
Is there any other way? Let's see. Uh, A1, can we start from A1, A2 and do anything else? No, right? A1, if you come to A1, you have to go to A2, right?
Yeah. Right.
And after that, you are going to have to go to A4. So these three are fixed, right?
Yeah.
And after that, there are only two possibilities.
Yeah.
So if you start with A2, you have to go to A4. These two are fixed.
Yeah.
Okay, there's only four. Hmm. So right now it is looking like the 7 is on overcount somehow, right?
Again, it's 2 square. A2 is 2.
Can you stop doing the squares and all? What is the logic of that? I don't understand what is the logic there. Do you understand what I'm saying?
Yeah.
Is there any logic to what you're doing?
No. No.
I'm saying that when we counted A6 here, suppose we are getting 7 according to our normal Fibonacci, but basically the three ways of A4 have to be subtracted from here, right?
Yeah.
Why? Because you have only one way from here to here, and looking at this, like, we can't go directly A5, right? So there is no way to go directly to A5 because A3 is not allowed. So basically, you have to remove this and you have to remove this, right? Still not perfectly clear, but we are getting only four paths though, right?
Yeah.
So what we are getting pattern is that you have to subtract this whole term number of ways of this.
Yeah.
Here we would have gotten 21, 11, but 11 minus 3, 8 would have been the expected answer. Hmm. So basically he's saying find out an and subtract a8 or whatever one was bad, right?
Yeah. Right.
All the ways of reaching a8 are subtracted. But when you find an, you also have to skip the an term properly and do it in a different way, the counting, right?
Yeah.
Okay. Still not perfectly clear, but we'll have to wait for the solutions, I guess. Maybe they will do something, maybe they will say something that makes sense. But the standard way in solving such questions is to set up a recursion like this, the way we did,
Right. Yeah.
because you can reach any step from two ways, right?
Yeah.
So that you should know that you have to do it like that. And
Right. Yeah.
then there are ways to sum up a recursion and all, how to find. Sometimes it is annoying and sometimes you have to use higher maths, but this kind of question I highly doubt will come in mains. This is not like a typical mains question.
Yeah.
This is more like a Olympiad type of question, IOQ.
What I had tried was like, so from A1 to A7, like we have to reach A7. There's no other way to go above.
Hmm.
So I mean, we can either take one step or two steps. So let's say we take X number of one steps and some Y number of two steps. Then I should have that 1 into X plus 2 into Y should be 7 steps.
Wait 1 second. We have to reach A7, so we can count A7 and then multiply it with this, right?
Yeah.
We have to reach A7 for sure,
Yeah.
because we will not be able to reach here.
Yeah.
To count number of ways of A7, we did that count right earlier.
Yeah.
1 second.
It was 21.
Okay, so great. So 21 ways is A7. And how many ways to go from A9 to A16, right? Oh, now you start the whole thing from the beginning. Okay, now it makes sense why it is 21 square. Do you understand what I'm saying?
But I thought we had gotten like A9 had like 22 methods.
But we have already reached here. We are doing it as an intersection of two events.
Okay. Okay.
We have already reached here, right?
Yeah.
We have after that, there is only one way to go from here to here.
Yeah.
So now we have already reached here.
Okay. Right.
So this event, A event has to happen and B event has to happen, right?
Yeah. Right.
You can count how many ways to go from A9 to A16, right?
Yeah.
And basically label it, subtract 9 and you'll get A0 to A7, right?
Yeah. Right.
These are just number labels.
Yeah.
So this is now a new Fibonacci. You're already here.
Yeah. Right.
There are 21 ways to do this.
Yeah.
Do you understand what is happening?
Yeah.
If it was A17, it would not have been 21 square, by the way.
Yeah.
The
Right.
part, the 21 square is not important. Do you understand what I'm saying?
Yeah.
It would be 21 times whatever is till A17, right? Which would be
Right.
A8.
Right. Yeah.
So it's not like square pattern is not the important part. But the important part is the realization that in order to go the journey, you have to reach A7 for sure. And then from A9, you have to go to A16.
Right.
There is only one way to connect these two. So we can count this separately and count this separately
Right. Yeah.
and use multiplication rule, right?
Yeah.
And counting this needs you to understand the recursion method.
Right. Yeah.
And if you do this recursion, then you will realize that it is coming Fibonacci sequence,
Right.
right? Like this. Are you
Yeah.
understanding? This is A0, this is A7.
Yeah.
So all of these concepts are used and now the answer is making sense.
Right. Yeah.
Okay, what is the next one?
That's it. Everything else I was able to solve on my own later.
Is there any questions that are taking too long or you have marked it as too long, didn't do or something like that?
No. Whatever I could do, I did.
Okay. No, there are some could do it, but takes time there. I can see it somewhere.
Those are all the old tests.
This is not test 15 and all. Oh, these are not the new ones.
No.
Okay. So that paper, did you get the paper for yesterday which you didn't attempt?
No, it was online.
So get it from some of your friends or something. You can't
Yeah.
download it.
I'll get it. I mean, they'll upload the thing soon.
Attempt all the questions, try everything, and we have to still do the questions on 3D and whatnot, right?
Yeah.
So we can do a class tomorrow or day after tomorrow whenever you're free, but we need to do it before in the next coming 2 weeks.
Yeah.
What is your
Right.
date of the exam?
29.
Okay, so then you have 2 weeks then. Focus on the chemistry part as discussed
Yeah.
and keep doing your basic revision. Don't spend too much time on solving tests and all right now.
Yeah.
Only Allen tests are required. You don't need
Yeah.
to do anything else.
Yeah.
Just focus on revision.
Right.
Okay, fine. That's all for now then.
Okay.
Mm.
Thank you, sir.
Mm.